In this video, I want to tackle one of the most frequent fallacies I encounter when talking about immutable design. Namely, so many programmers believe that immutable designs are less performant than the corresponding mutable designs in terms of how much memory they take, how many objects they create, how many garbage collections it takes to run them, how much CPU they spend. That view is not founded in data or even in how immutable designs work. But it's easy to understand why people believe that. You know, in an immutable design, every operation on an object creates another object, a new instance. So doesn't that mean that the memory consumption and the number of objects created will be at least twice as large as that of a mutable design, where any change can be done on the same instance? It looks so. It looks like immutable designs will take at least twice as much memory, at least twice as much garbage collections. But it doesn't happen. I mean, wouldn't we notice that? Wouldn't you be able to point your finger at a program and say, hey, look, this program is taking substantial amount of memory. It's taking so many garbage collections. But you cannot. Why? For example, think about C# compiler. I always point that example because we all use it. The C# compiler is blazingly fast. It doesn't take a lot of memory, right? And it is fully immutable. Can you explain that? Actually, it's very easy to explain, but before we can get to the point of seeing why immutable designs are as performant as the corresponding mutable designs, we must understand how objects are created and what happens in memory that explains that. So, I will show you an example. This is one immutable type that represents a money transfer. It comes with a whole bunch of properties. From the amount in currency to the account identities to some additional data, the timing of the transaction, the approval by supposed bank employees. It's all here. Now, any operation that involves this record type, which is immutable, means that a new record would have to be created. And all the values except the one that changed would have to be copied into that one. Isn't that wasteful? Wouldn't that cause the double amount of memory to be consumed? Yes, of course. The trick is in understanding that that's not how we write code. Let me explain. This record type is a DTO. Who needs a DTO? Nobody uses a DTO in a domain model. We need much more. We need validity. We need an object that cannot have an invalid state. We need polymorphism. What is this nullable date time here? It is the execution time of the transaction, which when a null tells that the transaction is not executed yet. Well, that tells us that there are two kinds of transactions or transfers. One is the pending one and the other one is the executed one. That is only one element that shows that my initial design, which is again just a DTO, is not the best design I could come up with. If I had to start this design over again, I would think about smaller objects that comprise this transfer, this large transfer object. This would be the money. Then the money with the account from an account to which the money is transferred would be the transfer itself, and the rest would be a money transaction that includes the transfer plus the additional data. Now, some of these additional data are just extras. Some others are more interesting, like these date times. That would be the window in which the transaction executes. What are these approvals? How did they get into the transaction? I think they don't even belong to the transaction. They are a completely different type. Compare this system of types with what I had originally, a single large type that contains all the values. This begins to look like proper software engineering. And the transaction we will be working with would be actually a very small object that references other objects, which also reference other objects and other objects. There would be what we call a graph of objects, and we would only have a reference to the root object in this graph, which represents what we want to have. Now try to imagine an operation on this object, for example, approving a transaction. Imagine that this is a pending approval. That means to create the approved transaction, but everything below will be reused. It could be a dozen other objects. Not a single one of them will be copied again. That is how we actually do the immutable design. And this has a name. In immutable designs, this is called persistent objects. The idea is to reuse as many objects as you can while you create new objects through immutable operations. In that way, you are significantly reducing the amount of new memory you will need for your operations, because all the memory is already taken by the objects that do not change. You're reusing them. Now, why don't we do that with immutable designs too? Well, that is a tricky question. You cannot reuse objects in mutable design because they are mutable. Imagine you did reuse them. Then two large objects would point to the same smaller object. What would be the result of that? If one object changes the content of that smaller object, which it possesses and controls, that inner object is mutable, so the outer object can easily change it. Now the second outer object would immediately notice the same change, but did it want to change that? Is that change correct for that object? Likely it will be a bug. For that reason, whenever you create mutable objects, you create everything under them again, because you're not allowed to share mutable references. You're not allowed to share mutable references among mutable objects, because that easily turns out into a bug at runtime. Below the line, it can turn out easily, very easily, that the immutable design will make total less number of objects during a large operation compared to the corresponding identical mutable design. In an immutable design, we reuse huge portions of allocated memory, and that is partly art, partly craft. You need to know a lot about the domain you're modeling. You need to do a lot of modeling in the first place to make all that work, but once you have that, you will have all the benefits we normally see in immutable designs. The principal benefit is that you will have much less number of bugs. That is a known fact. And on top of everything else, the amount of memory you will spend making all the operations you need to implement will not exceed the amount of memory used by the corresponding mutable design. By saving on memory allocations and garbage collection, you will also save a lot of CPU, so that CPU consumption won't also be larger or noticeably larger compared to the mutable design. Try immutable design out. Try to see how you can design the same solution but with maximizing reuse of immutable objects along the way, and you will be surprised how efficient an immutable design can be.